I make the analogy of popcorn. All right? Who's a popcorn maker that you might buy to get put to me? Orville Redenbacher. All right? Sort of like Orville Redenbacher popcorn that you might make. When you take that bag out of the box and you lay it in the microwave, is it popcorn? No. No, it's what? Kernels of popcorn. All right, you lay it in the microwave. Is it popcorn yet? No. No. All right? You close the door and you punch whatever, minute 30 or 2:30 or whatever it is on that. Is it popcorn yet? No. No. You hit start. It's immediately turned to popcorn. No. No. What has to happen? Has to heat up to a basic temperature and to a microwave level, and then all of a sudden the kernels start popping. Well, what's that threshold level like? It's like when it hits a quantum of energy. Okay? So, now, this action of going from an energy level out, there's a term for it that you've heard of. What is it called?
Is it quantum leap?
It is. Say it louder.
Quantum leap?
This is called a quantum leap. Have anyone ever heard of the phrase or terms quantum leap used in any sort of way? Yes. I would assume you would. If it was the 1980s or 90s or something, you might have been a fan of the show Quantum Leap. It's still out there on video and whatnot because there's kind of a cult following of the show. It's about time travel, Quantum Leap. Sometimes in advertising they use the phrase quantum leap. Like it's a quantum leap in
time.
It's like a quantum leap in
space.
Progress, automotive technology type thing. It's a good little catchphrase. It's a good advertising phrase. But where does it come from? Chemistry and physics. Literally, we're talking physics in this. It is the action of an electron moving from its ground state out an energy level. Okay? It's called a quantum leap when it absorbs a quantum of energy. Now, is this electron, which was in the ground state, is its quote-unquote stable position? It's not in its ground state anymore. When it has popped out, it's in a different state. What's the name of that state?
Yes, unstable.
Louder. Yes. It is now in the excited state. It is said to be an excited state electron, in which case it's unstable. It's not in its normal position, so it's unstable at this point. So we go from ground state electrons absorbing a quantum of energy, they go through a quantum leap to become excited, to excited state electrons. They go from being stable to unstable. They don't like being unstable, so how do they regain their stability? They go back. That's right. They only exist out here for microseconds, nanoseconds, gazillionths of a second type thing. And then what do they have to do is fall, I'll actually draw it on the bottom part. Then they will fall back. Now there's not really a name for this that I know of, like the opposite of a quantum leap. But they fall back and, well, if energy went in to get them to jump out, go through the quantum leap, what has to happen? Energy comes out. And they emit a...
Wait, they go back to their ground state?
Yeah. They emit a photon of light energy. Now, I kind of missed something here that I'll make up in just a second for. But they emit a photon of light energy. Well, the quantum of energy that can go in, this here, can really be, there's three major types of energy that will go in here. It could be heat, it could be light, like solar, or it could be electrical. Those are the three major types that will go in. But what comes out is light energy. But when we talk about light energy, anyone know the fancy word for light energy? I'll give you a hint. Keep going, Ellen. Magnetic energy. Very good. Okay, electromagnetic energy. All right. Which is part of it is a visible spectrum. What's that little name you learned in elementary school to learn the colors of the rainbow? Roy G. Bibb. Very good. So what we might see is the visible spectrum, and we'll learn more about this stuff when we do radiation stuff. We might be able to see it somewhere in the visible spectrum. Or it might be just beyond the visible spectrum, just beyond violet. What's that called? Ultraviolet. Someone actually said, wow, I get it, ultraviolet. It's beyond violet. Isn't that amazing? Thus, ultraviolet. Huh? The photon is always going to be light energy. We may be able to see it, but we may not. We can't see ultraviolet light. Some animals can. Okay? It could also be X-rays, could even be gamma rays. Okay? Or it could be inside of red, known as infrared. Or it could be like radio or microwaves given off, depending on what the photons are. But they're distinct packets of light energy, and they fall back. Okay? Yes?
What makes this electron disjunct?
Adding energy. Adding energy. Does it? Well, I don't know, Bowie. Come on down, and you're going to do something for me. But you are now my volunteer. All right? Let's get so you're on camera here. You'll be world famous. Okay? No, stand behind the ladder. Sit on it. All right. So Mr. Bowie here is going to play the role of electron number 11. He's going to play the role of the electron when it was here. When it's here, it is in that electron, or he, is now in his what? Ground state, his normal position. Turn around, face the ladder. Okay? And he is content, because that's where he normally is, and he is stable. Okay? Don't smile too much, because that'd be too much content. Okay? So he's pretty stable. Alright, what are we going to do to get him to move an energy level? We're going to add a quantum of energy. What kind of energy could we add?
Electrical.
We could add electrical, light, heat. All right, so maybe we get a big blowtorch. We get the heat. Stop blasting with heat. Okay? Or we get a big spotlight. Get some beam of light on. Blast on. Okay? Or we get like some jumper cables, hitch it up to batteries, start getting electric. Like this. Once it gets to a certain point, all of a sudden he is going to make a quantum leap up an energy level, in which case he is not in the ground state anymore, he's in the excited state. Now you can start looking excited. He's also very what at this point? Unstable. And he's excited and unstable. Whoa, so what does he do to regain his stability?
Falls back down.
Falls back to the ground state. And what he does, he gives off a photon of light energy, which is like a distinct packet of light. Okay, it might be red, it might be visible, or it might not be. Okay? Alright? Nice job, you're out of here. So, before we go wrap this up in just a second, no, where's this happening in this room right now?
Everywhere.
No, it's not happening in
Oh,
there.
right
there? No.
In the
Where?
sun. The lights.
In the lights. What kind of lights do we have in here? Fluorescent lights, okay? It happens in fluorescent lights. Now, we're pretty much, how many of you guys at home have fluorescent lights pretty much going in everywhere now? The funny looking ones. They aren't even now, you can get them so they aren't even that funny looking anymore. Right? The CFLs. Okay? They actually, they are not all that expensive anymore to buy. You can get them in pretty good deals on them. They put them in. How do they compare to the old? Pretty soon, people aren't going to know what I'm talking about when I say the incandescent lights. Students are going to look at me and say, what? The old lights. They do last longer. They also use less energy.